Hey everyone, let's get started. Today in this video, I will show you how to solve the problem find first and last position of element in a sorted array. The problem here is what we're given an array of integers sorted in non-decreasing order. We're asked to find the starting and ending positions of a given target value. Also, you must write an algorithm with an O log n runtime complexity. For example, if we have this input sorted array in a target integer of 8, the result will be index 3 and 4. This means the starting position is 3 and the end position is 4. So in detail, we know that the array is sorted and we know that the input is an array. The best technique to solve this problem is by using the binary search algorithm. Binary search is an efficient algorithm for searching for an item from a sorted list of items. It is known as the divide and conquer algorithm, or also as a half interval search or algorithmic search with a time complexity of O log n. Here's how binary search is going to work in this problem to search for the first appearance of the target in the array. First, we're going to start by initializing two pointers, left and right. Left starts at the first element in the array and the right at the last element in the array. Then we're going to calculate the middle pointer. After that, we check if the target is bigger than the current middle number. If true, we set left to be the next number after the middle index. Otherwise, if the target is smaller than the current middle number, we set right to be the middle index minus 1. The last condition is that if the middle number is equal to the target, we return the middle index. But with respect to some conditions, the conditions are the following. First, we start by checking if the middle is equal to 0. If true, that means there is no number before, so we return the current middle number index, which is 0. Otherwise, if the middle index is not equal to 0, we need to set another condition. If the number before the number at the middle index is not equal to the target, that means the current position is the first time our target appears, or the first occurrence of the target inside the array. If it's not, we move the right pointer to be the middle index minus 1. Let's use this input array so that I can show you how it's going to work. The target here is 8. We start by initializing two pointers. Left starts at the first integer in the array, and the right starts at the end of the array. Then we loop over the array using the two pointers, which means left is going to keep moving forward and right backwards until the left pointer passes the right pointer. Then we stop the loop. The left pointer starts at the first number 5, the right pointer at number 10. The first thing we need to do is calculate the middle by performing an addition operation, left plus right, divided by 2. Then we check if the target is bigger than the integer at the middle index. If it's true, we move the left pointer to start after the middle index. In simple terms, it's like we're eliminating the left part of the array so that we can search only in the right half of the array because we know that the target is bigger than the middle. After calculating the middle pointer, if we have a middle pointer equal to the target, remember, even if it's equal, we still need to check if it's the first appearance of the target in the array. We start by checking if it's index 0. Here the target is at index 4, so we move to the other condition to check if the previous number is equal to the target. Here is the previous numbers are equal to the target. So what we need to do is move the right pointer to the previous number and repeat the same process by calculating the middle pointer. Here is the number at the middle pointer is equal to the target, and it's the first time it appears in the array, so we say that we found the start of the target in the array. But this is not the final result because we still need to return the end of the appearance of the target in the array. Here is how we're going to find it, also by using a binary search algorithm. To find the last index of the target in the array, the same process will be repeated. The only difference will be in the condition where the target is equal to the number at the middle index. The condition is that if the middle index is pointing at the end of the array, or if the number after the middle index is not equal to the target, and the middle index plus 1 is less than the length of the array. In simple terms, we check if the next number after the target is not equal to the target. Otherwise, we move the left pointer 2 points at the middle index plus 1 and repeat the same process. This means we still need to search for the end of the target. Let's continue searching in the previous input array. We found the start at index 3. We repeat the same process by calculating each time the middle index. Once we have the number at the middle index are equal to the target, we're going to check if it's the last appearance of the number in the array. We're going to do that by checking if the next number is not equal to the target. Finally, we return to the start and the end indices of the target, which are generated from the two algorithms. The time complexity for this solution is O log n, because we're performing a binary search algorithm, and the space complexity is 101, because we're not using any data structure to store the output results. We're only using variables. That's it, guys. Now let's jump into coding the solution. First, we start by initializing a left pointer and set its value equal to a function that returns the starting index of the target inside the array. The function takes the nums, arrays, and the target as parameters. Then we initialize the right pointer and set its value to be a function that generates the ending index of the target in the array. At the end, we return an array that contains the start and the end indices of the target in the nums array. After that, we define the function to get the start index. We start by initializing the left and right pointers, left at the beginning of the array and the right at the end. Then we loop over the array using the 2 pointers while left is less than or equal to the right. We calculate the middle pointer by grouping left plus right divided by 2. Then we set 3 conditions. First, if the target is equal to the middle number, we set a nested condition. If the number at the middle index minus 1 is not equal to the target and the middle index is greater than or equal to 0, or if the middle index is equal to 0, we return the middle index. Second, else, we move the right pointer to the middle index minus 1, and else, if the number at the middle index is smaller than the target, we move the left pointer to the middle index plus 1. The last condition, if the number at the middle index is bigger than the target, we move the right pointer to the middle index minus 1. If the target is not found in the array, we return minus 1. The same thing will be repeated for the second function that generates at the end index. The only difference is that we have to change the condition when the target is equal to the number at the middle index. We say that if the number at the middle index is equal to the target, we set a nested condition that says if the middle index is the last index in the array, or if the number after the middle index is not equal to the target and the middle index plus 1 is less than the length of the array. We return the middle index, which represents the end index of the target in the array. Otherwise, if none of those conditions are true, we move the left pointer to the middle index plus 1 and restart searching for the end index. Finally, if the target is not found in the array, we return minus 1. All other conditions remain the same. And that's it. Thanks for watching.